meeting, and then we can begin. Okay. So, yung klase natin for today, okay, we're just going to build up on yung pinag-aralan natin last time na mag-meet tayo, which was on two particle systems. Okay, at ang ginawa natin last time is sinet up natin yung Hamiltonian, okay, for actually for multiple particle systems. So we had yung Hamiltonian, or we had yung kinetic energy term for each of the particles, yung potential term, okay, it's actually the electrostatic potential for each of the particles. And then yung third term ay yung electron-electron interaction term, okay, which is yung bagong term na pinag-aaralan natin ngayon. And if we ignore that term and we apply that to two particle systems, okay, makikita natin na merong, o ang total energy ng particle na yon is about 109 electron volts. Pero experimentally, it was about 75 electron volts, if I remember correctly. Okay, and yun yung gagawin natin ngayong araw. I-account natin yung difference na yun, okay, between the experimental at saka yung tawag dito yung theoretical. And the way to do that is to get the expectation value of the electron-electron interaction potential term, okay, dun sa Hamiltonian na discuss natin last time. Okay, now before we tackle that, okay, review muna tayo ng konti, okay, sa pinag-aralan din natin last time. Okay, yung itong problem na ito, let's start the review with this problem 5.4. Okay, sabi dito, we first write down the Hamiltonian for two identical non-interacting particles in the infinite square well, and then verify that the fermion ground state given in the example is an eigenfunction of H, okay, with the appropriate eigenvalue. Okay, and then find the new next two excited states beyond the ones given in the example, okay, wave functions and energies for each of the three cases. So distinguishable, identical bosons, tsaka identical na fermions. Okay, so unahin natin yung letter A. Okay, the Hamiltonian for two identical non-interacting particles in the infinite square well. So ang gagawin natin is first we write yung potential energy term, or kinetic energy term, negative h bar squared over 2m, and then d squared psi dx1 squared. So this is for the first particle. So dapat m1 yan. Okay, and yung second term, okay, is negative, h bar squared over 2 m2 d squared psi, okay, dx2 squared, okay, equal sa e psi. Okay, so kinetic energy, they are non-interacting particles. So hindi natin sila kailangan tawag dito, wala tayong interaction term. Plus, since this is an infinite square well, then hindi natin din kailangang isama, or yung potential dito is 0. So recall that inside the infinite square well, okay, yung potential is 0, and everywhere outside yung potential approaches infinity. Okay, so wala tayong potential term dito. So yan yung Hamiltonian for the two are identical non-interacting particles in an infinite square well. Okay, so verify that the fermion ground state given in the example is an eigenfunction of H. So recall, okay, na yung wave function for a fermion is given by square root of 2 over A, and then sine pi x1 over A sine 2 pi x2 over A minus sine 2 pi x1 over A, and then sine pi x2 over A. Okay, if we take the first derivative of that, okay, so let's say derivative with respect to x, o second derivative na, diretso na natin. Okay, so second derivative with respect to x1, okay, we get a square root of 2 over a. Okay, tapos negative pi over a squared sine pi x1 over a. Okay, sine 2 pi x2 over a, okay, minus a negative 2 pi over a squared sine 2 pi x1 over a sine pi x2 over a. Okay, and naintindihan niyo naman siguro kung paano nagkaroon ng pi a squared diyan kasi ito lang naman yung kinukuha natin derivative. So we only need to take yung derivative nito kasi with respect to x1 lang naman. So first derivative nito is cosine and then yung constant is pi over a. And then yung second derivative is against negative sign. So kaya may negative sign dito. Okay, so kaya ang coefficient is negative pi over a squared. And ganun din, similar case then for this coefficient here. Okay, next, we take the derivative, second derivative with respect to x2. So square root of 2 over a. Okay, then we have negative 2 pi over a squared sine pi x1 over a sine 2 pi x2 over a minus pi over a squared sine 2 pi x1 over a sine pi x2 over a. Okay, so again, kaya lumitaw yung mga coefficients na yan kasi we're taking the second derivative of this term here. Okay, so now we plug in these equations, okay, dyan and doon. Okay, and when we do that, okay, ano ang makukuha natin? So we have, well, we have the common, tawag dito, common coefficient na h bar squared, negative h bar squared 2m1, m2. And since these are identical particles, m1 is equal to m2 and sabihin natin m. So yung pinaka-coefficient niya sa labas is negative h bar squared over 2m. And then i-add lang natin yung second derivative with respect to x1 ng psi at saka yung second derivative with respect to x2 ng psi. Okay, at anong ibibigay sa atin dito? Okay, so let's see. Okay, so we have etong terms na ito. Yeah. So itong term na ito, tsaka itong term na ito na pareho. So i-add lang natin ito at tsaka yan. Okay, so negative pi over a, pi squared a squared, okay, minus 4 pi squared over a squared. And then sine pi x1 over a sine 2 pi x2 over a. Okay, and then minus, okay, so negative, wait. So dapat okay, okay. So ito, okay, magiging pi squared over a squared, 2 pi or 4 pi squared over a squared minus pi squared over a squared. Okay, times sine 2 pi x1 over a sine pi x2 over a. Okay, Okay, and nakalimutan ko yung coefficient dito. So dapat meron ka pang coefficient dun. So this will give us negative h bar squared over 2m. And of course, nakalimutan ko rin yung coefficient na ito na square root of 2 over a. Okay, so common term naman sa kanila yung negative pi squared a squared. Okay, so negative 5 pi. Negative 5 pi squared a squared. Tapos square root ng 2 over a sine pi x1 over a sine 2 pi x2 over a minus sine 2 pi x1 over a and then sine pi x2 over a. Okay. And of course, this is nothing but yung ating wave function. So we end up with negative h bar squared over 2m or positive. So 5 pi squared a squared. Okay, at equal yan sa, sorry, psi at equal yan sa e psi. Okay, okay, which means na, wait, sandali. So, sorry. Itong h bar squared kasama yan sa psi. So, hindi natin yan i-include dito sa. Okay. So, 5 pi squared over a squared. And then, of course, huwag natin kalimutan yung negative sign niya. So, ang e natin ngayon, okay, no, hindi siya pala kasama. Okay, sandali figure out ko lang ito. 5 h bar squared pi squared over 2mn. Okay, tama pala. So, hindi pala siya kasama. Okay, so, h bar squared over 2m. So, ibig sabihin, ang e ay equal sa 5 h bar squared pi squared over 2ma ma squared. Okay, and ang gagawin lang natin dito is we already know yung expression for a. Okay, and pag pinasok natin yung expression for a dito, we'll find that yung e will be equal to 5k. Okay, so yung expression for a na yan ay makikita natin sa equation. So, a is 4 pi epsilon naught h bar squared m e squared. So this is equation 4.72. Okay, and then yung e, okay, if you recall, is h bar squared k squared over 2m, okay, or equals a negative me to the fourth over 8 pi squared epsilon naught squared h bar squared rho naught squared. So this is equation 4.69. Okay, now, iiwan ko na sa inyo na gawin ito kasi what I would really like to do is to move on dun sa next problem. Okay, and again, yung next problem involves taking the or figuring out kung bakit may difference between yung theoretical value na 107 electron volts, 109 electron volts, tsaka yung experimental value na 75 electron volts. Okay? So yun yung gagawin natin dun sa next na problem. Okay, so ito yung next na problem. Okay, so sa problem na ito, okay, we're going to calculate yung expectation value ng 1 over R1 minus R2, okay, for the state psi naught. So equation 5.30. Okay, recall that this is the electron-electron interaction term. Okay, so ang hint dito is first do the volume integral ng d3r2 using spherical coordinates and then set the polar axis along r1 so that r1 minus r2 ay equals to r1 squared plus r2 squared minus 2r1 r2 times cosine theta 2. Okay, the theta 2 integral is easy. Okay. But be careful to take the positive root. So you have to break the R2 integral into two pieces, one ranging from 0 to R1 and the other from R1 to infinity. Okay, the answer is 5 over 4A. Okay, and then sa letter B, use your result in A to estimate the electron interaction energy, okay, in the ground state of helium. Okay, express your answer in electron volts and add it to E naught to get a corrected estimate of the ground state energy. Okay, and then compare the experimental value. Okay, so yun yung task natin dito. Okay, so let's begin with the expectation value. So 1 over R1 minus R2, okay, ay equal sa, okay, so 8 over pi a cube, okay, squared, then double integral ito, okay, ng exponential minus 4 R1 R2 over A, everything divided by square root ng R1 squared plus R2 squared minus 2R1 R2 cosine theta sub 2. And then D3R2 tapos D3R1. Okay, so paano nakuha yan? So malamang tatanungin nyo paano nakuha yan. Well, recall na yung expectation value, okay, ng isang for example, the variable x is integral, okay, from integral ng psi star, okay, and then x and then psi dx. Okay, so yung psi natin dito, okay, so yung psi na tinitignan natin dito ay, okay, so psi naught R1, R2 ay equal sa 8 over pi a cube exponential minus 2 R1, R2 over 8. Okay, diniscuss natin to last meeting. This is equation 5.30. Okay, so yung sign na, so pag in-square natin yan, di ba, wala namang complex number dito. So basically, square lang natin siya. So we have 8. So dyan ang galing yung term na to. Okay, mula dito sa coefficient na ito. Of course, ito, 4 siya, di ba? Magiging 4 siya, kaya naging 4 yan dyan. And then yung x natin is yung 1 over R1, R2. Pero sinabi natin from here, okay, na yung absolute value ng R1, R2 ay given by that expression. We have double integrals kasi we have two variables, R2 tsaka R1. And ang suggestion is to do D3R2 first, okay, using spherical coordinates and then setting the polar axis along R1. Okay. So, yun. So, I hope naintindihan nyo kung saan galing itong equation na ito. It's a direct application of the definition of the expectation value gamit itong wave function na ito. Okay, so next is now we're going to evaluate yung first na integral. Okay, ang una natin evaluate, of course, ay ito munang integral na yan. So, one by one natin i-evaluate yan. So, yung integral na yan, exponential minus 4 R1, R2 over A all over R1 squared, R2 squared minus 2 R1, R2 cosine theta 2 square root then D3 R2. So, sabi express natin in spherical polar or spherical coordinates. So, in spherical coordinates, we have integral from 0 to infinity, integral from 0 to pi, and the integral from 0 to pi. Okay, ng exponential minus 4 R1 plus R2 over A all over R1 squared plus R2 squared minus 2 R1 R2 cosine theta 2 and then R2 squared dr2 tapos sine theta 2 d theta 2 and then d phi 2 d phi 2. Okay, baliktad yata na dapat nauuna yung okay. So dapat since d phi nasa labas ito yung 2 pi and then ito yung infinity. Okay. So in any case, yung integral ng d phi 2 okay, is just tawag dito 2 pi. Right? Okay, so pwede na natin siyang i-factor out. Okay, so equal yan sa 2 pi. Okay, and then we are left with these two integral. So 0 to infinity ng exponential minus 4 R1, R2 over A. Okay, and then integrate muna natin yung terms involving theta 2. So sine theta 2 all over R1 squared plus R2 squared minus 2 R1 R2 cosine theta 2. Okay, and d theta 2. So R2 squared d R2. Okay, so ito yung unang integral na integrate natin. And then of course, after natin integrate yan, integrate naman natin with respect to dr2. Okay. Oops, yung ginawa ko. Okay, so let's move here. Okay, so ang next step is we let, pwede pa dito, u be equal to yung nasa loob ng radical. So R1 squared, R2 squared minus 2 R1 R2 cosine theta 2. Okay, we take the derivative with respect to theta. And we end up with 2 R1 R2 sine theta 2 d theta 2. Okay, which is fortunately nandun sa taas. Okay, so yung integral na yan na nasa loob, okay, will give us, okay, so this will give us 2 pi and then 0 to infinity ng exponential minus 4 R1 R2 over A. And then yung integral na sa loob will give us du over u to the 1/2. Okay, and then yung coefficients na 2R1, R2. Okay, galing dito. Okay, yan. Okay, and then of course ano yan? R2 squared. R2 squared dr2. Okay, so itong integral na ito, okay, leads to u to the 1/2 over 1/2 or 2u to the 1/2. Or, okay, if we replace it, so 2 pi 2r1 r2 0 to infinity ng exponential minus 4 r1 plus r2 over a, we get 2. So magiging 4 ito. Okay, hindi. Sorry. 2 pa rin yan. Okay, yung 2 na ito at saka 2 na ito magka-cancel. So we have 2 pi r1 r2. Okay, and then so square root ng r1 squared r2 squared minus 2r1 r2 cosine theta 2 evaluated from, sabi natin 0 to pi, okay, and then r2 squared dr2. Okay. So if we evaluate that, we have 2 pi over r1 r2 0 to infinity ng exponential minus 4 r1 r2 over a. Okay, and pag in-evaluate natin yan, we have r1 squared plus r2 squared minus, ano bang cosine ng pi? It's negative. So that's plus 2r1 r2, wala na yung cosine. And then minus r1, square root. Huwag natin kalimutan yung square root. r1 squared plus r2 squared. And then 0, cosine ng 0 is 1. So we have minus 2 r1 r2. And then square root. Okay, tapos r2 squared dr2. Okay, now we're going to do a simple trick here. Okay, we know na itong term na ito na nasa brackets, okay, ay equal dito sa absolute value ng R1, R2. Okay, so ganito ang gagawin natin. So equal to sa 2 pi. Yeah, iwan pa natin siya sa loob ng integral. Okay, for now, so 0 to infinity ng, dapat pala hindi natin nilabas sa integral itong mga ano. Okay, so anyway, just keep in mind na nung dinerive natin yan, dapat nasa loob pa rin siya ng integral. Okay, now let's do it right. Okay, so over R1, R2, over R1, R2, and over R1, R2. Okay, so exponential minus 4, R1 plus R2 over A. Okay, tapos, itong first term is R1 plus R2. Okay, yung vector. Minus yung second term na R1 minus R2. All over R1, R2. And then R2 squared dr2. Okay. Now, yung R1 plus R2, yung absolute value ng R1 plus R2 is just equal to R1 plus R2, di ba? Kasi hindi naman siya magiging negative kasi you're just adding these two numbers. Pero yung R1 minus R2, posible yan maging negative, depende sa kung alin yung mas malaki. So let's say na if R2, if R1 is greater than R2, okay, then yung term na yan, okay, becomes R1 plus R2 minus R1 plus R2. Okay, mas malaki yung R1 kaysa R2, so yung absolute value ng R1 minus R2 is positive. Okay. Okay, syempre L over R1, R2. And also we don't need to use vector notation anymore kasi kinuha na natin yung absolute value nila. So we end up with 2 over R1. Okay. Now, if R2 is greater than R1, then what we end up with is R1 plus R2 minus R2 minus R1. So pagbabalik rin natin para positive yung lalabas. So, ang sinasabi ko is R2 minus R1 over R1, R2. So in this case, ang magka-cancel is yung R2. We have 2 over R. Okay? So, dito na papasok yung sinasabi dito sa problem na you'll have to break the integral into two pieces. One ranging from 0 to R1 and the other ranging from R1 to infinity. Okay, so kasi yung first integral is valid when this condition is obtained and the second integral is valid when this condition is obtained. So itong integral na ito becomes, so 2 pi. Okay, so it will have two terms. First, 0 to R1 kung saan yung R1 is greater than R2. So exponential minus 4 R1 plus R2 over A. Okay, ito magiging 4 pi kasi ipapasok natin yung 2 doon. And then divide natin yan by R2, R1. So pwede natin siyang ilabas kasi etong integral na to ay with respect to dr2. So, sulat ko lang na maayos. So 1 over R1, integral from 0 to R1 ng R2 squared exponential minus 4 R1 plus R2 over A. And then dr2. Okay, so yan yung first integral. And then yung second integral, okay, will range from R1 to infinity kung saan yung R1 is less than R2. So we have R2 squared dito divided by R2 dito. So we end up with just R2 exponential minus 4 R1 R2 over A. Okay. dr2. Okay, and since ito naman ay integral over R2, so pwede ko nang ilabas din yung exponential minus 4 R1 over A. Okay, para lang hindi ganun ka-confusing pag nag-integrate tayo. Minus 4 R2 over A dr2 plus integral from R1 to infinity. Now, R2 exponential minus 4 R2 over A dr. Okay? Okay. So, ano ang first integral? Parati tayo nakaka-encounter ng ganitong klaseng integral. R2 squared exponential. Okay, and then R1 exponential. Ibig sabihin, R to the n e to the minus u. So, dapat medyo familiar na tayo kung paano i-treat ito. So, evaluate muna natin yung unang integral. Okay, yung unang integral, okay, if we let, so ang unang integral is 1 over R1, 0 to R1, R2 squared, exponential minus 4, R2 over A, dr2. Okay, and if we let u be equal to 4, R2 over A, this means na ang du ay equals sa 4 over A dr2. Okay, and then this gives us R2 is equal to U over A divided by 4 o ang R2 squared ay equals sa U squared A squared over 16. Okay, so anong mangyayari dito ngayon sa ating integral? So, equal ngayon to sa 1 over R1. Okay, R2, may merong ganitong coefficient. Okay, A squared over 16. Tapos ang DR2, ito yung DR2, ng coefficient niya is A over 4 du equals to DR2. So meron ka pang ganong coefficient. So we end up with A cube over 64. Okay, so integral from 0 to R1 ng u squared e to the minus u du. Okay, and yung integral na yan is just negative e to the u, negative e to the minus u squared plus 2u plus 1. Okay, 0. Evaluated from 0 to R1. Okay. So that gives us 1 over R1 A cube over 64. Okay, exponential minus. So ibabalik muna natin lahat, ano? R2 over A, and then 16 A squared R2 squared plus 8 over A R2 plus 2. Okay, evaluated from 0 to R1. Remember yung ating integration variable dito ay R2. Okay, so pag pinasok natin ngayon yung R1 dyan, we have 1 over R1. Okay. Exponential negative 4 R1 over A. So yung R2 na yan is just, ay may replace ng R1 dun sa upper limit ng integral. And then A over 4 R1 squared plus A squared over 8 R1 plus A cube over 32. Okay. So yan yung para sa upper limit na R1. And then yung sa lower limit, okay, dito sa lower limit na ito, okay, i-replace natin ito with 0. Okay, and if we replace that with 0, we end up with just 1. Ito i-replace natin with zeros. Ito i-replace natin with 0. So we have just simply 2. 2 multiplied by this coefficient. Okay, so ang matitira is plus a cube over 30. Okay, so yan yung first integral. The second integral involves integral from R1 to infinity ng R2 exponential minus 4 R2 over A dR2. Okay, again, if we let u be equal to 4 R2 over A, yung du ay magiging equal sa 4 over A dR2, and yung R2 ay UA over 4. So, yung integral na to gives us A squared over 16 kasi may coefficients ka dito, U over 4, 4 over A, 4 over A. A over 4, tama. Okay, so A squared over 16, and then evaluated from R1 to infinity, ng U e to the minus U du. Okay, and pag in-integrate natin yan, we'll end up with A squared over 16, integral from R1 to infinity ng, hindi. Negative e to the minus u plus 1, R1 to infinity. So we have A squared over 16. Then balik natin yung R2 dito. So negative exponential minus 4 R2 over A. 4 R2 over A plus 1 Okay, from R1 to infinity. Now, evaluate natin over infinity, yung integral, this becomes 0. And if you evaluate yung integral with respect to R1, we have a squared over 16, okay, e to the minus 4r1 over a, 4r1 over a plus 1. Okay, and pag pinasok natin yung coefficients na yun, so exponential minus 4r1 over a over 4r1 plus a squared over 16. Okay, so yun na yung dalawang integrals. Okay, so, yeah. Okay. So, ang sinol pa lang natin ay yung itong naka-box in orange. Okay, so going back to this whole equation. Okay, we have so expectation value now R1 minus R2 equals 8 over pi a cube squared and then integral, okay, ng 4 pi exponential minus 4 R1 over a, and then 1 over R1. Okay, ito yung first term, first integral, exponential minus 4 R1 over a over 4 R1 squared plus a squared over 8 R1 plus a cube over 32 plus a cube over 32. Ako na lang plus a plus exponential minus 4 R1 over a over 4 R1 plus a squared over 16. Curly brackets. And then yung integral na d3r1. Okay, makikita natin na okay, so ito magka-cancel. Okay, and pwede natin i-add itong dalawang terms na ito. Okay, tapos, hindi, sorry, not those two terms. Bakit hindi yung two terms na yun? Kasi meron ka pang R1 dyan. So, pag pinasok mo yung R1 dito, magka-cancel yung R1 dyan. And then we can add these two terms instead. And then itong term na to will involve 1 over R1. So, we have then 8 over pi a cube squared. Okay. Integral ng 4 pi. Okay, so a cube 32r1 exponential minus 4r1 over a plus negative a squared over 16 minus a squared over 32r1 then exponential minus 8r1 over a then d3r1. Okay. Naintindihan niyo naman kung bakit naging 8 yan, no? Kasi pinasok ko na multiply ko na yung exponential na nasa labas sa loob ng curly brackets. Okay, so equal to sa 8 over pi a cube squared. So we end up with integral ng Okay, pi a squared over 8. Okay, simplify natin lahat. A over R1 exponential minus 4 R1 over A minus 2 plus A over R1 exponential minus 8 R1 over A d d3 R1. Okay, so kaya naging ganito yung mga yan kasi finactor out ko yung a squared over 16, a squared over 32. Okay. So yung a squared over 32 finactor out ko. Kaya naging ganyan yan. Okay. And then, dito kumuha rin ako ng a squared over 32 tsaka a squared over 32. Okay. So the expectation value of R1 of the absolute value of the reciprocal of the absolute value of R1, R2 ay equal ngayon sa 8 over pi a to the fourth. Okay, after simplification, okay, multiply ako dito ng 4 pi. Okay. Saan galing yung 4 pi na yan? Okay. So, yan, ito, nanggaling yan by multiplying just these two coefficients. Okay, now, ang gagawin natin is, isusulat na natin yung integral na yan in spherical polar coordinates. So, you have 0 to 2 pi, 0 to pi, and then 0 to infinity. Okay, ng exponential ng, a over R1 exponential minus 4 R1 over A minus 2 plus a over R1 exponential minus 8 R1 over A. So R1 squared dr1. Then meron ka pang sine theta 1 d theta 1 dyan at saka d phi 1. Okay. Pero yung integral ng d phi 1, okay, will just give you 2 pi. And this one, yung integral nito, will give you 2. Okay. So kaya, pag sinulat natin ito, 8 over pi, a to the fourth, magiging, or magkakaroon ng 4 pi dyan. And we are left with the integral from 0 to infinity of a over r1 exponential minus 4 r1 over a minus 2 plus a over r1 exponential minus 8 r1 over a r1 squared d r1. Okay. Pause tayo sandali para tawag dito. Ma-absorb nyo ng konti. Alam kong tawag dito, hindi siya madaling i-absorb especially sa ganitong mode. Okay? Kasi wala naman ako nakukuha feedback galing sa inyo. Pag face-to-face, kitang-kita yung mga mukha ninyo eh. So, natatanong ko kaagad kung kailangan balikan, and of course kayo rin, tinatanong yun kung anong nangyayari in between steps. Okay. Okay, sige. Let's continue. 1 over R1 minus R2. Okay. Expectation value. So, magiging 32 over A to the fourth. Okay, pag pinasok natin yung R1 dito, okay, sa bawat terms, okay, dyan, we get A integral from 0 to infinity ng R1 exponential minus 4 R1 over A minus 2 integral from 0 to infinity. Sorry, hindi yan from 0 to infinity. From R1 from R1 No, 0, 0. Oh, sorry. Okay. 0 to infinity ng r1 squared exponential minus 8r1 over a d r1, okay, minus a integral from 0 to infinity ng r1 exponential minus 8r1 over a d r1. And then close square brackets. Okay, so tatlong integrals to. Okay, so the first integral, 0 to infinity ng r1 exponential minus 4r1 over a dr1. dr1, if we let u be equal to r1, du is equal to dr1, then dv is equal to exponential minus 4r1 over a dr1. So v is equal to exponential minus 4r1 over a all over negative 4 over a, or negative a over 4 exponential minus 4 r1 over a. Okay, so yung integral na yan gives us nag-integration by parts tayo. No? So a over 4 r1 exponential minus 4 r1 over a evaluated from 0 to infinity plus a over 4 okay, 0 to infinity ng exponential minus 4 r1 over a dr1. Okay, itong term na to gives us 0. Okay, bakit? Kasi yung evaluation from the integral, evaluation of the integral over infinity sa upper limit gives us 0. And evaluation with respect to the lower integral gives us 0 dahil dito sa factor na yan. Okay, so equal to 0 plus a over 4, and then ito straightforward lang to na integration. So that's negative a over 4, yung coefficient ng r1. Okay, so exponential negative 4 r1 over a evaluated from 0 to infinity. So yung upper limit niyan gives us 0. Pero yung lower limit gives us 1. Okay, lower limit na exponential. Lower limit na integration dun sa exponential gives us 1. So we end up with a squared over 16. So yun yung first term. And then we can also evaluate yung second or yung third term muna, r1 exponential minus 8 r1 over a dr1. Ano mag-iiba rito? So ang iba rito is ito 4, ito 8. So ito magiging, yung mga 4, lahat ng 4 dyan, magiging 8. Right? So, pag ibig sabihin, yung 4 na nandito, yung 4 na nandiyan dyan, magiging 8. So we have, imbis na 4 dyan, magiging 8 yan. So we have a squared over 64. 8 times 8. Okay. Then, yung second integral, the r1 squared exponential minus 8 r1 over a dr1. Okay. So if we let u be equal to r1 squared, and then du is equal to 2r1 dr1. Okay, so ang dv is equal to exponential minus 8 r1 over a dr1, which means na ang b ay equals to negative a over 8 exponential negative 8 r1 over a. So this gives us, so uv negative r1 squared a over 8 exponential minus 8 r1 over a evaluated from 0 to infinity plus 2a over 8 integral from 0 to infinity ng R1 exponential negative R1 over A d R1. Okay. Again, evaluating this result over infinity, okay, ito ang bibigay sa ating exponential is 0. And then, pag in-evaluate mo sa lower limit, ito naman yung magbibigay ng 0. So 0 multiplied by that number, okay, is 0. So yung first term is 0. Plus, okay. So, again, ano tayo? Integration by parts. So du is equal to dr1, v is equal to exponential negative 8r1 over a dr1. So dv dapat yan. So v is equal to negative a over 8 exponential negative 8r1 over a. Okay, so plus, first term is, remember may coefficient dito. So 2a over 8 times negative a over 8 ng R1 exponential negative R1 over A 0 to infinity plus 2a over 8 negative a over 8 integral from 0 to infinity na exponential negative 8R1 over A d R1. Again, if we evaluate this term, ito magbibigay ng 0. And with respect to this term, ito naman yung magbibigay ng 0. So again, yung second term is also 0. So we end up with 0 plus 0 plus 2. Okay, pag in-evaluate natin itong integral na ito, okay, from 0 to infinity, yung first term is evaluated to infinity, that will give us 0, and yung second term is evaluated, yung term na yan evaluated to 0 will give us 1. So we have 2 times a squared over, meron ka pang coefficient na 8 over a dyan, di ba? So actually magiging 2a cubed over 8 cubed. Okay, so 2 times a over 8 cubed. So yun yung second term. So 1 over R1 minus R2 absolute value. It finally gives us, so 32 a over 8 to the 4th. Okay, tapos may coefficient tayo na a, ito ay a squared over 16. So a times a squared over 16. And then dito naman may coefficient tayo na 2. Itong integral na ito ay 2a cubed over 8. So minus 2 times 2a over 8 cubed. And then minus yung third na integral, may coefficient na a. And then ito ay equal sa a squared over 64. So a times a squared over 64. Okay. Kasi multiply natin yung a to the 4th. Okay. Okay. So we have 32. 1 over 16a minus 1 over 128a minus 1 over 64a. And then multiply natin yung 32, we have 2 over a minus 1 over 4a minus 1 over 2a, or this is just 2 minus 1/4 minus 1/2 times 1 over a. Okay, so ang expectation value ng 1 over R1 minus R2, okay, absolute value squared is just 5 over 4, which is yung in-expect natin na sagot dito. So answer is 5/4. Okay, any questions? Okay, so let's move now to the second question. Use will result in A to estimate the electron energy. Okay, electron interaction energy in the ground state of helium. Okay, okay. So let me just show quickly yung expression na inaano natin. Okay, so ano ko gagawin to? Screenshot. So for helium, ito yung ating kinoconsider. Okay. Okay, so for letter B, yeah. Okay, so yan yung kinoconsider natin. Okay. Ito yung kinuha na natin na expectation value, yung 1/R1, R2. Okay. So ibig sabihin, to get the energy or the full potential has to include itong E²/4 pi epsilon naught. So yung electron potential includes E²/4 pi epsilon naught. Okay, expectation value ng R1 minus R2. Okay. So, so 5/4 E²/4 pi epsilon naught 1/A. So yung A, sabi natin kanina, ay 4 pi epsilon naught E² H bar squared over M. At yung E1, yung ground state is negative M over 2H bar squared E²/4 pi epsilon naught squared. So yung VEE ngayon is 5/4 E²/4 pi epsilon naught. Okay, so 1/A. So we have E²/4 pi epsilon naught M over H bar squared. So this is equal to 5/4 E²/4 pi epsilon naught squared tapos M over H bar squared. Lalagyan ko dito ng 2. Siyempre, tatanggalan ko to ng 2 dyan. Okay, and itong expression na ito is nothing but yung E1, right? Or negative E1. So 5/2 negative E1. Pero this is negative 13.6 electron volts. Okay, so ang negative E1 is 13.6 electron volts. So ang VEE is 5/2 times 13.6 electron volts, which is 34 electron volts. So recall, okay, na yung E naught na makukuha natin from these two terms, so yung corresponding na eigenvalue dyan ay negative 109 electron volts. Okay, so yung total is, of course, E naught plus VEE. Diba? So E naught and then yung makukuha natin dito ay VEE. Okay, so equals to negative 109 electron volts plus 34 electron volts. Okay. or negative 75 electron volts. So yung experimental value is actually negative 79 electron volts. Okay, so, but introducing itong term na ito, okay, brings the value from 109 electron volts down to the more realistic, closer to the more realistic value of negative 79 electron volts. Okay, at yun ay dahil sa electron-electron interaction. Of course, what you can do is to involve tawag dito, higher order terms. Okay, but not sa helium kasi sa helium dalawa lang eh. So dalawang electrons lang yung nag-interact. Eh. So may iba pang terms na involved dito or may iba pang pinanggagalingan ng tawag dito ng difference itong experimental at saka yung theoretical. And that's something that we are going to consider pagdating natin sa perturbation theory. Okay, so that's all I wanted to show to you today. Okay, so just a couple of announcements lang. So, dali lang. Patayin ko muna to. Zoom. Okay, stop share. Stop ko na rin yung mag-record dito.